Welcome to the Frontend Interview Playbook, your complete guide to mastering React, modern ecosystems, and distributed system design for senior-level US interviews. Over the next 10 minutes, we'll walk through every topic this deck covers, from semantic HTML and CSS architecture, through React Fiber and concurrent rendering, custom hooks, mega frameworks, white label architecture, all the way to caching topologies and the CAP theorem. Whether you're prepping for FONG, a Series B startup, or a staff-level architecture loop, this playbook gives you structured, memorable answers, not buzzwords. Each slide maps to a real interviewer question. Watch the highlighted chips on screen as we go. Those are the keywords you want to land in your answers. Let's load interview prep at senior level and get started. Every front-end interview follows a funnel, and smart candidates adjust depth at each stage. At the top, interviewers ask broad, open-ended questions to assess high-level understanding. What is the virtual DOM? Why does React exist? How does semantic HTML matter in 2025? Start concise. Give a crisp two-sentence answer, then stop talking and let them steer. In the middle of the funnel, they narrow to implementation. Walk me through the render, pre-commit, and commit phases. Design a custom hook for high-frequency side effects. Compare CSS and JS versus CSS modules for an enterprise app. This is where you show step-by-step process, working code, and trade-off analysis. At the bottom, they probe edge cases, the questions that separate senior from mid-level. How does Fiber enable incremental rendering? How do you prevent excessive re-renders when state updates cascade through a tree of 200 components? How does your UI behave when a network partition hits during a checkout flow? Pro tip from the debugger panel on this slide. Start concise, pause for cues, and drill deeper only when the interviewer signals interest. Volunteering Fiber architecture before they ask reads as unfocused. Waiting for the cue and then delivering depth reads as senior. That pacing alone separates candidates who get the offer from those who stall at mid-level. Let's start with foundations that still win interviews, because senior loops absolutely test whether you understand the platform beneath React. First, semantic markup. Interviewers ask, why does semantic HTML remain crucial in the era of React components? 3 reasons. Accessibility. Native elements expose area roles to screen readers and assistive technology automatically, without bolting on area label everywhere. Pseudo search algorithms prioritize structural elements like article, section, and nav over generic div clusters that carry zero semantic meaning. And maintainability. Readable document trees make code review and onboarding faster for every engineer on the team. React 19 now natively extracts title and meta tags from any component depth and automatically hoists them into the document head, a game changer for metadata in component-driven apps. Next, CSS specificity without exclamation important. Interviewers love this one. Use the colonies pseudo class to group selectors. It adopts the highest specificity of its arguments. Use colonware to reset specificity to 0, enabling scalable overrides without fighting the cascade. Combine them in a 0 specificity override strategy. Colonies header comma hashnav, .btn, colonware hover, powerful, maintainable, and interview ready. Finally, optimizing a massive render blocking style sheet. Hit 4 pillars. Delivery, minify payloads, compress with Brotli or gzip, enforce aggressive cache control headers. Architecture, adopt declarative flexbox and grid, minimize costly paint and reflow calculations. Critical path, inline above the fold styles and defer non-essential style sheets so first paint isn't blocked. Pruning, audit dead code with Purify CSS or Chrome DevTools coverage analytics. Pro tip. React 19 precedence attribute on style sheet link tags natively manages loading priority. Mention that, and you signal your current on the ecosystem. A classic implementation question. Would you use native HTML5 APIs or a library to implement drag and drop? Walk through the native lifecycle first. It proves DOM mastery. Drag start, attach your data payload with data transfer.setData. Drag over, Call prevent default on every frame to allow dropping. Miss this and nothing works. Drop, extract the payload, prevent default again, and update your React state. 0 external dependencies. Incredibly lightweight, perfect for Kanban boards with simple move semantics. But when the UX gets complex, collision detection between nested drop zones, multi-list reordering, touch support, and keyboard-accessible drag handles, reach for React DND or DND Kit. Know both paths and explain the trade-off out loud. Then the paradigm question every senior loop includes: contrast declarative and imperative UI programming. Vanilla JavaScript is imperative, step-by-step manual DOM mutations. You grab a node, change its text, append a child, toggle a class. Highly susceptible to out-of-sync state, brittle conditional logic, and layout thrashing when reads and writes interleave. React is declarative. UI is a pure function of state. You describe what the screen should look like given current state. The rendering engine diffs the virtual tree and applies minimal, optimized DOM updates. That one sentence, UI equals F of state, is the anchor every senior answer needs. Follow it with a concrete example. A to-do list where you set state with new items instead of manually creating and appending lie elements. When they ask how React updates the screen under the hood, walk through 3 phases in order. This is one of the highest value answers in the entire playbook. Render phase. React constructs the work-in-progress fiber tree from your component output. Operations here are asynchronous and interruptible. React can pause, resume, or abandon work to keep the main thread responsive. Pre-commit phase. React batches all required DOM mutations into an effect list. No UI changes are visible to the user yet. This is the quiet preparation stage. Commit phase. Batched updates hit the real DOM synchronously. This phase cannot be interrupted. Consistency matters. Use layout effect fires here before the browser paints. Key concept to land. The virtual DOM calculates what needs to change. The fiber engine schedules when it happens. For re-render diagnosis, walk through the 3-era evolution on this slide. Era 1, identify. Profile with the dev tools flame graph to spot wasted render cascades. Red bars mean components re-rendered without prop or state changes. That's your target list. Era 2, the manual era. Apply React.memo, use memo, and use callback. Powerful but prone to stale closures, missed dependencies, and over-optimization that makes code harder to read than the problem it solves. Era 3, the automated era. The React compiler in React 19 analyzes dependencies at build time and injects auto-memoization without developer overhead. Mention all 3 eras. It shows historical depth and awareness of where the ecosystem is heading. Interviewers love candidates who understand the why, not just the API. System design questions love custom hooks. They test whether you can extract reusable logic with correct lifecycle management. For high-frequency side effects, use debounce is the canonical answer. Export a generic function, use debounce of T. Generics guarantee strict type safety whether you're debouncing a search string, a numeric filter, or an object. Inside, useState holds the debounced value, initialized to the incoming value. UseEffect sets a timeout that updates state after the delay elapses. The cleanup function clears that timeout, crucial to prevent memory leaks and stale network requests when the user types faster than the delay. Walk through the dependency array. Value and delay both must be listed. For 10,000 items without freezing the UI, use transition is your answer. It splits urgent updates from deferred ones. Typing in a search input is urgent, set query fires immediately. The input stays snappy. The user feels 0 lag. Heavy list filtering over 10,000 records is deferred. Wrap set results in start transition, so React executes it in the background, fully interruptible. If the user types again before filtering finishes, React drops the stale work. The isPending flag lets you show a subtle spinner on the results panel without blocking the input. These 2 hooks together demonstrate you understand correctness, type safety, and performance at production scale. Prop drilling becomes an anti-pattern when intermediate components pass props they never use just to reach a deep child. The result is brittle, high-friction code that breaks every time the tree reshapes. The fix on this slide is direct delivery via a context provider near the subtree that actually needs the data. Use context for localized shared state, theming locale, authenticated user profile. For high-frequency global state that updates many times per second, think live cursor position, audio playback progress, or real-time stock ticks. Adopt external stores like Zustand or Redux with selector subscriptions to avoid rendering cascades. Rule of thumb: context for low churn shared data, external stores for hot global state. On styling at enterprise scale, interviewers want a structured comparison, not a fanboy take. CSS and JS like emotion, component-bound execution. Excellent dynamic styling that reads React props directly, but runtime overhead and struggles with server components. CSS modules, locally scoped via hashed class names, zero runtime execution, highly optimized builds, but limited native dynamism without inline style overrides. Utility-first Tailwind, exceptional build speed, tree shakes unused classes, but dynamic variants need CLSX or CN concatenation utilities. There's no universal winner. Match the strategy to your rendering model, your team's CSS comfort level, and whether you're shipping server components. Why adopt a mega framework like Next.js over a standard React single-page app? Answer with the rendering spectrum: 3 modes, 3 use cases. Client-side rendering on the left. The browser downloads empty HTML and a heavy JavaScript bundle, then hydrates. Ideal for interactive, gated dashboards where SEO doesn't matter. Server-side rendering in the center. HTML generated on the server per incoming request. Ideal for dynamic, SEO-critical content like product pages with real-time inventory. Static site generation on the right, HTML pre-built at compile time and cached on edge CDNs. Ideal for high-traffic marketing pages that rarely change. The conclusion interviewers want: mega frameworks enable hybrid rendering, mixing CSR, SSR, and SSG seamlessly within a single unified architecture. One code base, route-level rendering decisions. For white-label UI architecture, walk through 4 layers bottom to top. Base layer, agnostic React component logic, a generic button that knows nothing about brands. Config layer, JSON injection mapping brand-specific tokens at build or runtime. Theming layer, CSS custom properties translating config into visual rules, like --primary : FF000. Asset layer, dynamic favicon and logo swapping via environment variables in CI/CD. True white labeling decouples branding tokens from functional behavior, so your pipeline builds infinite client variations from one single codebase. Staff-level loops go beyond components into distributed systems, and this deck's second half is where you prove architecture fluency. Start with the N-tier blueprint. Edge tier, your React client UI served through a global CDN caching static assets. Gateway tier, an API proxy or backend for frontend handling rate limiting, cores, and authentication before traffic hits microservices. Services tier, decoupled auth, inventory, and payment services that scale independently. Data tier, relational database plus Redis in-memory cache shielding heavy queries. N-tier separation enables independent scaling, specialized edge caching, and isolated team deployments. For cores blockages, give both environments. Production, set access control allow origin on the Express backend to your trusted UI domain, never wildcard in production. Local dev, configure a Vite proxy routing /API to your internal backend, with change origin true so the browser sees same origin requests. Global asset strategy follows the 4-tier caching ladder. Client memory first, browser local storage, TAN stack query cache, HTTP cache control headers. Edge CDN second, geographically distributed nodes caching HTML, CSS, JS, and imagery. Application tier third, in-memory node. JS caching or BFF response memoization, distributed cache fourth, Redis clusters shielding the primary database. Rule of thumb, cache as close to the user as physically possible, invalidate as granularly as possible. Finally, CAP theorem. During a network partition, a distributed system must sacrifice consistency or availability. Front-end engineering typically favors AP, availability plus partition tolerance. Show cached, optimistic UI rather than freezing the interface, then sync consistency in the background once the network recovers. You've reached the final slide, the holistic front-end engineer. Modern mastery sits at the intersection of three circles: UI craftsmanship, semantic HTML, CSS architecture, accessibility compliance; React internal, fiber scheduling, concurrent rendering, hooks, and the compiler era; distributed system, caching topologies, API gateways, and CAP theorem trade-offs. The summary line on this slide says it perfectly. Modern front-end mastery requires orchestrating decoupled systems, commanding rendering engines, and crafting resilient user experiences. You now have the full playbook, structured answers from broad concepts through edge cases, with code, architecture, and system design woven together across all 20 slides. Practice each section out loud. Pause for interviewer cues. Drill deeper on demand. Use the funnel framework every time, concise first, depth when invited. Good luck in your next loop. If this helped, like and subscribe for more senior front-end engineering content. Now go ace that interview.